Hi folks, welcome to this short video on setting up provisions for large and small populations. Some of you indicated that it might be a good idea to have a little video on provisions where you needed to use probabilities. So I thought I'd focus on the large and the small populations. And I guess the first thing we need to talk about is the only time you would record a provision is if it's more likely than not that there's going to be a payout. So only if there's at least or over a 50% chance or likelihood that you're going to make a payout, that's the only time you'd set up a provision in accordance with the current standards. Now, if it's not probable or if payout isn't likely, then under IFRS you can set up a note disclosure and set it up as a contingency. Under ASPE, they're a little bit different. They say if it's estimatable and accurately estimatable and there's a strong likelihood of occurring, so 52% wouldn't do it for them, it'd have to be pretty high up there, then you would record it. Otherwise, just disclose it. So you can see that IFRS has a tougher standard because even if the probability is 52% that you're going to make a payout, you have to make an entry, set up a provision. But under ASPE, you don't. You don't have to do that. And we record the provision at the best estimate. Now, if it's the case that the payment under the provision won't be made for a long time to come, say 2 years, 5 years, whatever, we would set that provision up at its discounted present value. So let's talk a little bit about the large and the small populations where we have maybe lots of claims if it's large, lots of warranties, those kinds of things, and we have to set up a provision. The best estimate we use is the expected value, but don't forget, we're not going to set anything up unless we know there's an excess of a 50% chance of a payout. So now if I have a look here at my example for a large population, it says here, assume I have 80 warranty claims that could go as high as $8,000 each, and the company estimates that 40% of the claims are likely to be paid at the maximum amount, 20 at $5,000, and 40 with no payout. Well, right away I can see there's at least a 60% chance in my mind that I'm going to have to make a payout because there's a 40% chance that I won't. So because it exceeds the 50% standard, then I have to set up a provision. So the question is how much? Well, if it's a large population, it's easy. You calculate the expected value. So I would say, well, there's a 40% chance that I'm going to have to pay out. There's a 40% chance, or there's a, well, not reading the question right now. 40% of the claims, so 32 claims, would likely be paid out at $8,000. We expect only 20% of the claims to be paid at $5,000, so 16 claims to be paid at $5,000, and 40% of the claims, which again would be another 32 claims, would have no payment. So under the expected value approach, we would say we need to set up a provision for $336,000, and that's what we do. Now, if we had a look here, well, I guess we didn't do it, but we could set up the entry for warranty expense, and that entry would be $336, and here warranty or estimated obligation under warranty, or provision I should say, I guess, just to keep it, provision for warranty, and that would be $336. Don't mind the underlining. I'll get rid of it if it bugs you. There you go. So that's how we would set that up. Now, what if we have a small population? I suspect that this is where students are coming a bit undone. You still have to use the fact whether or not there's a probability of payout that exceeds 50%. That standard's always there whether it's small or large population. The question is, when there is, how do I calculate the best estimate? You use the most likely outcome. But you also should calculate the expected value and the cumulative probabilities, because if the most likely outcome is less than the expected value and cumulative probabilities, then you might say maybe I should use the expected value or a cumulative probability, depending on what you calculate here. If the most likely outcome exceeds the expected value or the cumulative probability, then you'd use the most likely outcome, right? So let's look at some small populations. It says here a lawsuit is filed against a company for $500,000. There's a 10% chance we pay in full. There's a 90% chance we pay nothing. So there's no provision set up because there is a 90% chance we pay nothing. So there's less than a 50% chance that we pay anything. In fact, there's a 10% chance that we pay anything at all. That is far less than 50%. So because the likelihood of payout is less than 50%, we set up nothing. Okay? Now, what about example 2? A lawsuit is filed for breach of contract against our company for $10 million. The lawyers estimate there's a 70% chance that we're going to pay in full. Okay? And a 30% chance of dismissal. So now we know there's at least a 50% or more than a 50% chance we're going to pay in full. So we need to set up a provision. Now, under our rules, it would be based on the most likely outcome. Well, the most likely outcome is paying in full, 70% chance, and that means we'd pay $10 million. But what does expected value say? Would it be more than that? And when we calculate it, it's not. So we would set up the provision at $10 million because the most likely outcome is more than the expected value. Now let's look at a third example. The third example says we have a lawsuit for $2 million that was brought against the company for lost profits after an information system failure. The legal department estimated there's a 5% chance that the suit will result in a $1 million payment, 60% chance that a $500,000 payment would be made to settle the suit, and a 35% that there's no payout. So that tells me right away that I know there's a 65% chance of a payout, so I know I need to set up a provision, but how much? Well, I can calculate the most likely outcome is 60% chance, right? Because it's the highest probability. So I could set it up at 500,000. But probably, in order for me to know, use judgment. Find the EV, expected value. And if I calculate the expected value, if I did it, 5% chance of $1 million, 60% chance of 500,000, and 35% chance I pay nothing, the expected value falls way short of the most likely outcome. So right now I'm sticking with that, right? If I used cumulative probabilities, I'd get the same answer. Because again, cumulatively, there's a 65% chance, 5% plus 60%, that I'm going to pay out a minimum of 500,000. So again, my most likely outcome coincides with the cumulative probability, but my most likely outcome is still the highest, right? It's equal to the cumulative probability, but it's definitely higher than the expected value. So I'm going to set up my provision at 500,000. Now, one of the things that we say here, after we've set up this provision using most likely outcome, you would say, well, is there ever going to be a time when we don't use the most likely outcome? Well, yeah. We said sometimes for small populations, it's not always the case that the most likely outcome is always the best estimate. So let's look at an example where that might be the case. Let's say we have 3 lawsuits that are outstanding in a company. The company lawyer believes that there's a 40% chance that one lawsuit is going to be paid out, and it's $100,000. There's a 30% chance of 2 suits, each at $100,000, and there's a 30% chance that we'd pay out on all 3, and they're $100,000 each. So now, I'm just repeating the rule here for small populations. It tells me to use the most likely outcome. We're going to assume that payment would be made within the year, so we're not going to bother with discounting. So what are we going to do? Well, right away, if I look at it, I say the most likely outcome is $100,000, right? Because it's the highest probability. The most likely outcome is the one with the highest probability, the one with the highest probability. So I look at that, and I say, okay, maybe that's it. But logic tells me no. If I look at the cumulative probabilities, I know that there's a 60% chance that I'm going to pay out on at least 2 suits. 30% chance of paying out on 2, which is 200,000, 100,000 each, and a 30% chance of paying out on 3, which could be 300,000. So I'm looking and I'm saying, well, there's a 60% chance that I'd pay out on at least 2 of them. So maybe my cumulative probability is a better estimate. Why would I say that? Because it's giving me cumulatively a 60% chance of paying out $200,000, and that's greater than my most likely outcome. So right away I'm saying, well, cumulative probability is higher than the most likely outcome, so the most likely outcome probably isn't enough. So I would say the most likely outcome is really 60% chance that I pay out at least 2 claims, and maybe I should be setting up $200,000 and not just based on this most likely outcome, the highest probability being 100,000. So I'm thinking it's probably more like 200. But let me calculate the EV and see. Well, if I said there's a 40% chance of paying out 100,000, a 30% chance of paying 2 times 100,000 on 2 suits, and 30% of chance of paying 3 suits at 100,000 each, then that's 190,000. So now I could turn around and I could say, well, hey, it's 190,000, which is still more than the most likely outcome at 100,000, which is the most likely outcome is the one with the highest probability. But if I now look at this and say, well, most likely outcome at 40%, 100,000, even the EV is bigger than that. So now I have to decide, am I going to take the expected value or the 200,000? Well, the fact that they're so close together, you could probably take either one. But you could justify 200,000 as easily as you could justify 190. But you cannot justify, in this case, taking the most likely outcome, that being the one with the highest probability. You can't do that. So you'd have to justify 190 or 200 because they're so close. All right? And that is the last example we have. So hopefully this has helped you to understand setting up provisions based on probabilities a little bit better. So thanks for your time, and have a good day.